we're going to have this lesson, Unit 4, Lesson 10. We're going to be talking about inequalities and how to solve for inequalities with two variables. We're going to do this graphically, which is going to end up being a really good review of our linear relationships and how we're going to graph those linear relationships in this unit. So just a little review in terms of the signs for this. This sign here is greater than. And then this one is less than. And I know you've seen these before. In these notes, we'll use this one as greater than or equal to. But sometimes that can be written like this or with an equal sign there. It sort of depends on the font that different books or worksheets may have used. And then this one here, we'll put a line underneath that means less than or equal to. So the difference between a linear equation or a linear relationship and a linear inequality is that the linear equation, that's our equation of a line. That finds all of the points that are have those x and y values that exactly fit that relationship. The other type, the inequality, would be more like this. Y is less than or equal to, that's this symbol here, 3 over 2x plus 3. So that means that the y values could be anywhere less than or equal to this line. So there's this straight line, the same as there, but then we're going to shade an area of the graph to show that all of those y values would be less than or equal to that. So we'll do a few examples here. So our first step, if we were to graph this relationship, is just to graph the boundary line. So y equals x minus 2. And we're going to determine if the boundary line is solid or broken. Broken also meaning like a dotted line. So if you have a greater than or less than, your line will be dotted. And if you have a greater than or equal or less than or equal, then you'll have a solid line. So when we're graphing this, I see that this is just greater than, so that's going to be a dotted or broken line when I graph. So I'm going to go back and think about what we did with our graphing and my boundary line y equals x minus 2. So we can think about this with transformations, that this would be a vertical shift. It's going down 2 squares. Or we could say that that's the initial value or the y-intercept or the b. And I have a rate of change or slope of 1. So I could look at this different ways. I think most people probably like the rate of change method. So when I go to graph this, I'm going to have an initial value of -2. So I'm going to count down 2 and put a dot. Now, when I'm graphing, if it's a regular XY graph, if you're going on a scale where each square counts as 1, you don't have to label each number because otherwise it gets really crowded. If you're changing your scale and say counting by 2s or counting by 5s, then you have to tell me that. So I'm going to start at -2, and then I'm going to count my rise and my run. So this has a rise of 1 and a run of 1. So I'm going to count from here, just erasing those little marks I made to get to my -2. I'm going to count up 1, over 1, and put a dot. My rise of 1, run of 1, put a dot. Rise, run, put a dot. So I'm going to do this a bunch because I don't have a ruler to use on my device here, and I'm just going to be freehanding this line. But when I go here, draw a nice straight line. You guys will be using a ruler on your test and on your homework. So here I've got this line. This is y equals, y equals x minus 2. And I just noticed I'd made a mistake. At the very outset, I said, oh, I'm going to use a dotted line. Luckily, I have an erasing tool here because when I drew this in, I did not draw a dotted line. I drew a solid line because I was kind of working on counting my rise and run and trying to make my line straight. So I'll go back in there and I'll erase all those little triangles I did for my rise and run. So because this is not the equal to, I don't have a solid line, my values are not going to go that far up. So I need to graph that line first, solid or broken, and graph that line, just like what we did before. See, this is why this is really good practice for the graphing that we did earlier in the unit. The second step, step 2 here, just to highlight this, we're going to choose a test point and test it on my inequality. So test point. I'm going to pick 0, 0 because I think it's the easiest one. And I'm going to say, put that in for my inequality of y is greater than x minus 2. So is 0 greater than 0 minus 2? 0 minus 2 is -2. And I have to decide, is this true or false? Is 0 greater than -2? Yes, it is. So if it's true, I'm shading the area where the test point is. If it's false, then you shade the other side. So I'm going to go and switch to kind of a highlighter here. This is true, so this number does work. And then I just kind of go in, and if you're using a pencil, this is harder for me to do on the video, but you would just kind of shade lightly with your pencil everything above that line. So we'll do another example. First thing is that you pick whether this will be dotted or solid. And I would like to see you write that down. Because that has the equals underneath, it's less than or equal to, that's going to be a solid line. So I'm going to graph my boundary, y equals 2x plus 2. So my slope, or my ROC, is 2, and my initial, or y-intercept, I'll put ROC here as well, is also 2. So for 2, for the slope, that's rise over run. So that's a rise of 2 and a run of 1. And my initial value, or my y-intercept, is positive 2. So I'm going to go up to 2 and put a dot. Then I'm going to count rise of 2, so up 2 and over 1, and put another dot. And do that a few more times. Up 2, over 1, and put a dot. And I will kind of get all of those dots along the way. I'm going to go back in and just erase the kind of steps that I showed. So when I draw this line as straight as I can, you guys, again, using a ruler, now this one is going to be a solid line. So that's a line with a stretch that made it steeper and a shift up by 2. I'm going to test the point 0, 0 again. So here, y is less than or equal to 2x plus 2. So 0 is less than or equal to 2 times 0 plus 2. 0 is less than or equal, now solving this, 2 times 0 is 0 plus 2. Is 0 less than or equal to 2? Yes, it is. So that's true. So I'm going to shade in the area where that 0, 0 is. So I would just go and shade everything under here. So you're looking, where was that test point? You're coloring in that part of your graph. Just very lightly. You don't have to color it super dark so that I leave it light enough that I can see. Okay, last example. Here we've got y is greater than or equal to 3 over 2x plus 3. So here I know that this will have to be a solid line when I graph it. And I'm going to graph this line. Y equals 3 over 2x plus 3. So the ROC, or the slope, is 3 over 2. And the initial, or y-intercept, is 3. Remember, we should be able to pick those out right from the graph. Then the ROC means that your rise is 3 and your run is 2. And my initial, or my starting value of 3, I'm going to start on the graph at 3 squares up from the origin. Then I'm going to do a rise of 3 and a run of 2 and put another point. And I'll do that a couple times. I can even backtrack a little bit and make sure I get a nice set of points that are all in a straight line. I'm going to draw my nice straight line through there and label. And if I made a bit of a mess showing my rise and run, I'll go back and erase that as well. Now my test point, you can test any point. Maybe I'll show just to test another point, just so we see. I like 0, 0 because it's easier for math, like easier calculations. What can I put in here? Maybe I'll test the point 2, 1. So that's my test point, 2, 1. It could be anything. So I'm going to put in x is 2 and y is 1. And I just put that into my inequality and see if it's true. So y is greater than or equal to 3 over 2 x plus 3. So y is 1, and that's greater than or equal to 3 over 2 times 2 plus 3. So 3 over 2 times 2, those 2's would reduce and just be 3 plus 3. 1 is greater than or equal to 6. So is this true? Is 1 greater than or equal to 6? That is not true. So where that test point is, I don't want to shade this area in because that was not true. I want to shade the opposite area up here. So I'm going to go and pick a highlight color here and just kind of shade in the area up above that line. I'm not shading in the test point because the test point ended up being wrong. 1 is not greater than or equal to 6. So there's a couple, I think 6 of these graphs. The most important thing is being able to graph those lines. And then from there, you're just figuring out, are you shading in the stuff above it? Typically, if it's a greater than, or the stuff below it, typically if it's a less than. And you can use your test points to double check.